Okay, so we're going to be starting on 6.3 today. Okay, what it says at the top is difference of squares, difference of cubes. We're actually just going to be doing difference of squares today. So 6.3 is actually going to take 2 separate days instead of 1, especially since we had this quiz thrown in there today. So today shouldn't be too bad. We'll go ahead and get started. First things first, we've got to list the 3 characteristics of how to recognize difference of squares. Okay? And here's what they are. Your first term that you see is a perfect square. What does it mean to be a perfect square? Yeah. Okay. So in terms of shapes, yeah, a perfect square would have all equal sides. Think about numbers, though. If I square a number, has anybody ever heard of a perfect square in terms of that? So for instance, 4 would be a perfect square because 2 times 2 equals 4, and that's the same number. Okay? Kind of going back to what Sean said, if I had a square and it was a 2 by 2 square, okay, it would equal 4. Same thing for, let's say that I had 16. Would that be a perfect square? If I take the square root of it, do I get a whole number? What would it be? 4. Yep, 4 times 4 is 16. Okay? What about 6? Would 6 be a perfect square? No, okay, because we don't get a whole number if we square root 6. Does everybody know how to type a square root into your calculator? Okay, for those of you who don't, put the calculator in your hand, okay? Here's what you're going to type in. You need to hit the second button, which is up in that left corner, okay? And then you're going to go down, and you're going to hit the x squared button, okay? Because right above it is this little square root symbol. Okay, so when you square root a number, you just type that number in after that symbol. So if you type in square root of 6, what do you get? Yeah, a decimal, right? So that's not going to be a perfect square. You with me? But now I want you to type in the square root of 169. 13, would that be a perfect square? Yes, it would. Okay? So, my first term must be a perfect square. Secondly, there must be a subtraction sign between the 2 terms. And lastly, my second term must also be a perfect square. Okay? What if I had x squared? Would that be a perfect square? If I square root that, do I get a whole variable back out? Well, wouldn't the square root symbol and the exponent of 2 just cancel to give me just x, right? You with me? Have we seen this before? Square root symbol and exponent of 2 will cancel. Okay. So looking here on example 1, my first term here, we said x squared. That is a perfect square, right? Is 64 a perfect square? Yeah, what is it? Yep, 8 times 8. Okay, so how we do this? So we know our first term, the square root of that is x, right? And we said the square root of the second term was 8. So how I factor this, I need x plus 8 and x minus 8. Okay, so you need a plus sign between the first 2, a minus sign between the second 2, after you've square rooted both terms. Okay, and that's it. That's your answer. That is how you factor when you have 2 perfect squares and a subtraction sign. So we should have that written down. Okay. Next one. Does this follow my rule? We'll start with 9v squared. What's the square root of 9v squared? 3v, right? And what's the square root of 4? 2. So I need 3v plus 2 and 3v minus 2. And that's it. How do we feel about this? Good? All right, I want you to go ahead and do examples 3 and 4. Okay, I see a lot of us have left number 3 blank. Why'd you do that? Is it because we didn't know it, or is it because maybe it doesn't follow a rule? 4x squared plus 121. Is that a difference of squares pattern? Yes or no? No, why not? Plus sign. Okay, so this one doesn't work. It does not work. I cannot factor that with difference of squares. So we're just going to skip it. Okay, cannot do difference of squares when we have a plus sign. All right, what about example 4? Well, if I look, is 10 a perfect square?
No.
Is 40? No, but what was the first thing we always check for when we factor? Greatest common factor. Do 10 and 40 have anything in common? 10. So if I take out a 10, what's going to be left? Y squared minus 4. Okay. Now the inside, is that a difference of squares? Can y, y is a perfect square. Is 4 a perfect square? Is there a subtraction sign? Yeah, okay. So what will that break down to? Y minus 2 and y plus 2, and then I just leave my 10 out front. And that is it. Questions on that? Okay, now that you know to check for a GCF first, why don't you try number 5? All right, what is the GCF on this one? 6. Anything else? Do they both have a variable in common? What? R. Cool. When I take out 6r, what is going to be left? So, yep, r squared. Negative 25. Cool. Is the inside now a difference of squares? Can I square root r, and can I square root 25? I sure can. Okay, and what will that break down to? Yep, r plus 5, r minus 5 in whichever order, and then that 6r needs to stay out front because that was our GCF. Cool. Questions on that? We feeling okay today? This isn't too bad, is it? It's awful. It's not awful. Okay, we're going to go ahead. Last but not least is just this page, and then we're done with notes for today. Okay? So it says up top, to solve polynomials, you must get them into factored form. We know that. We've been doing that this whole chapter, okay? So if I look, n squared minus 81 equals 0. Is that left side? Well, first off, is everything on a side by itself with 0 on the other side? Yeah. Yep, so it's in standard form, okay? Is the left side, is that going to break down? Yep, is it a difference of squares? I think so, because I think I can square root n, I can square root 81, and I have a subtraction sign right there, right? What will this break down to? N minus 9, n plus 9 equals 0. When I'm in factored form set equal to 0, what's the last thing I have to do? Yep. Set each part equal to 0. Good. Break it apart. So n minus 9 is 0, and n plus 9 equals 0. And then we just solve. What are my two answers going to be? 9 and negative 9. Cool. Questions on that? All right, number 2, do those have a GCF in common? Well, first off, everything's set equal to 0. So now I look, do they have a GCF in common? 2x squared and negative 72? Cricket, cricket. Look at the numbers, 2 and 72. 2 will go into both of them. And what's going to be left? X squared minus 36. Good. Finish it from there. And then go ahead and do number 3 as well. Okay, what does the inside break down to? X minus 6 and x plus 6. Good. Keep our GCF out front. And now what? Yep, set each part equal to 0. So we did x minus 6 equals 0, x plus 6 equals 0. And what'd you get, Emma? Yep, negative 6 and 6. Good. Cool. One question that you might have is, why do I not set this GCF equal to 0? Well, you should, okay? But can 2 equal 0? Nope, so those are just going to cancel out. That's not going to be an answer, okay? If it doesn't make sense, leave it alone. Questions on that? Okay, and last but not least, number 3. Is this in standard form? Nope. What do I need to do? Subtract what? The 27 over. Okay. Now we look, is there a GCF in common? 3. And what's going to be left?
X squared and 9.
Good. Will that break down further?
No.
X squared minus 9?
Will it?
I don't know. Will it? 3 times x minus 3x plus 3, right? Because square root of 9 is 3. Oh. And then lastly, set each part equal to 0. So 3 equals 0, x minus 3 is 0, and x plus 3 is 0. This one's going to cancel, and my two answers are just going to be 3 and negative 3. Questions on that? Okay. Any objections if we skip the word problem? All right, so that is it for today. That is just part A of this. We will finish it up next class. Make sure you do the Delta Math, and then on your homework, if you go to the homework packet, this is important. Go to your homework packet right now. You just have to do questions 1 through 4. Those are the only ones you're going to know how to do so far. Don't try to do the others or they're not going to make sense. So homework problems 1 through 4, and then Delta Math, there's I think like 14 problems on there. So not a bad day. Get going.